Hi everybody, I'm Erin. I'm going to be doing a Physics 6B problem from a class that I'm taking here at UCSC. This is a homework problem from chapter 20, number 10. So it says, a wave travels with speed of 200 meters per second. Its wave number is 1.5 radians per meter, and they're asking what are its wavelength and frequency. So the first thing I like to do is recognize what they're giving us and write them down. So the first thing they tell us is the wave travels with speed or velocity of 200 meters per second, which is saying that for every 1 second that passes, the wave travels 200 meters. So I have that written as velocity equals 200 meters per second, and then it also says its wave number is 1.5 radians per meter. So wave number can be kind of tricky to think about if you don't have practice with it. So I wrote down what it means. Wave number equals the number of waves per unit distance. So kind of similar to frequency. I like to relate it to frequency a bit. Frequency is number of waves per unit time. So when I say wave, I mean like when you think of a sine wave, one wave or oscillation, it can also be called, is one full turn of the wave. So wave number again is counting the number of waves per unit distance that it passes. Okay, so to start answering the questions that they ask, we start with part A, and they want to know the wavelength. So then we begin to think about what relationships do we know between what they're asking and what are given to us. Think of which formula may work for this problem. So we know a relationship between wavelength and wave number. And that formula is given as wavelength, or lambda, equals 2 pi over k. And 2 pi will always be constant here. It's the same for this relationship every time. And okay, so we have lambda, which is wavelength, on the left side by itself. So all we need to do is plug in k, which is given. Lambda equals 2 pi over 1.5 radians per meter. Okay. So now all you need to do is plug this into your calculator, and you should get wavelength equals 4.2 meters. Okay, now for part B, they ask about frequency, and frequency once again is number of oscillations per unit time. And now we want to think of a relationship or a formula that involves what's given and what they ask for both. Okay, so we know that we have a formula that involves frequency and wavelength, and that formula is frequency equals velocity over wavelength. Okay. So now, once again, we have frequency on the left by itself, already solved for. So what we want to do is just plug in our given and solve for our unknown. So we have frequency equals velocity, which is given, it's 200 meters per second, and lambda, which is what we just solved for in the denominator, which is 4.2 meters. Now plug it into your calculator and you should get 47.6, and then the inverse of seconds. And when you round up, you'll get 48 hertz, and the inverse of seconds are equal. These are the same thing. This is the units of hertz. So that should about sum it up. Thank you.